Hello everyone, welcome to Gate Forum. So let's start this video. This video is very important because we are going to discuss important things about the subject strength of material. As we know in Gate examination, this subject plays a very important role for both mechanical as well as civil engineering. Suppose if your gate aspirants, you are going for mechanical or going for civil in gate 2025 or gate 2026. Okay, 2025 or 26. So what happened? How you should proceed with this subject, I'm going to tell you. Because most of the students used to afraid with this subject, that very numerical subject. So many numericals in this subject, so many formula in this subject. That's why I'm here to tell you what should be the right approach first of all, what should be the things you should keep in your mind, and from where you should start this subject, and what should be the procedure to deal the subject here. Okay, so we will discuss each and everything so that you can get a very clear idea how to start this subject and how to finish this subject for your gate examination. And in this subject, in this video, we will also covering the weightage and important areas also. Okay, with the previous data also, I will be showing you the previous data from where questions will be coming more, and which topic you should prepare in the best way, like this only. Okay, so let's start this video. Okay, so here for mechanical and civil both I am telling you. First of all, let me tell you for mechanical and civil both. Okay, subject strength of metal, in short we are calling it as SOM, strength of material here. Okay, so we are starting from the overall subject in any particular year of the gate examination. Suppose if you are going to appear in gate 2025, you're going to open gate 2025. So out of 100 marks, because since we know now that gate exam is of 100 marks, total 100 marks here, and we need to score out of 100 marks. So what is the weightage of this subject only, strength of material, out of 100 marks? How many questions generally used to come from this subject, and how many marks we are going to discuss here? So let me tell you, roughly 8 to 10 marks, roughly 8 to 10 marks. First of all, every year we can expect roughly 8 to 10 marks from this subject, very important subject. Because out of 100, if we are getting 10 marks, that means 10% weightage here. We are very good weightage in both mechanical as well as civil engineering here. So here we have year by year data here, as you can see on the screen. Here we will start from year 2023, last data 2023. Okay, so here in 2023, here we have 1 marks question, 3 questions of 1 marks, and 5 question of 2 marks asked in the gate examination, and total of 13 marks. As you can see, 13 marks weightage. I have told you on an average 8 to 10 marks, but it can be more than 10 marks also. It can be little bit lower than 8 marks also. On an average, I have told you that 8 to 10 marks, or average you can say 10 marks, or average you can say 10 marks. Just you can see here in gate 2013, in gate 2013 here of 13 marks here we have. So very important subject first of all. Okay, and very basic subject also, because once you go for strength of material in the best way, definitely you can go for the other subject best way, because this is a very basic subject based for the other subjects also in mechanical as well as in civil engineering. Okay, here in gate 22, two paper here we have, paper 1 as well as paper 2. Here we have 1 marks 2 question, and 2 marks 2 question, 6 marks here we have. And here we have 1 marks 2 question, and 2 marks 3 question, 8 marks here we have. So in 22 here we have 6 marks, 8 marks weightage out of 100 marks. And here in 21, paper 1 as well paper 2, you can see here 7 and 6 mark, 1 marks question also, 2 marks question also, 1 marks question also, 2 marks question also. In 22, you can see in 22, paper 1, paper 2 also, here we have 7 marks and 7 marks. As well as in 19 also, in 18 also, you can see here 11 marks, 7 marks, here 12 and 11 marks here. Okay, so you can see 12 marks. So on an average, I can say 9 to 10 marks is on an average. Every year you can expect 10 marks question from this subject, strength of metal, as you can see this data here. So here similarly for 17, for 16, for 15, 14 here we have. Okay, and average you can say 1 marks question on an average we have 2.5. That means 3 question on an average we have of 1 marks question, and 3 questions on an average of 2 marks, and near about you can say 9 marks, near about you can say approx 9 marks on an average from this subject in mechanical as well as civil. Okay, you can consider it as around 10 marks on an average out of 100 marks. If you're going for mechanical, if you're going for civil engineering in the coming gate examination, gate 2025, then you can expect 10 marks question in both paper, gate mechanical as well as gate civil, out of 100 marks. That's why very important. First of all, this subject is very important, strength of material. Definitely you should go for, because not only from the marks point of view, but from the basic concept as well as this is the base for the rest of the subjects in mechanical and civil also. And let me tell you one thing, whenever any coaching starts, every coaching generally starts mechanical and civil engineering from this subject only, that is the strength of material. Suppose if you start your journey of gate examination for 2025, then definitely the first subject you will get, that is the strength of material, because this subject plays a very important role for the rest of the other subjects of mechanical as well as civil engineering. Okay, so first of all, we come to know that overall weightage is near about 9 marks or 10 marks here we have. Okay, let's move to the next. That is the strength of material syllabus. Here we have strength of material syllabus. Here we have, so just we will go through the syllabus or the topics here. So first chapter we will discuss simple stress and strain. Generally students start from here only, and any coaching institute or any faculty used to start from here only, simple stress and strain. That is the basic concept here. And then principal stresses, which is also known as Mohr circle. Second chapter, which is also known as Mohr circle, student used to call this as Mohr circle chapter Mohr circle. Okay, second chapter is the Mohr circle, that is the analysis of stress and strain of principal stress and strains of plane stresses. Okay, third chapter will be very important, shear force and bending moment diagram, and fourth one will be the bending of beams, fifth one will be the torsion, sixth one will be the deflection of beams. Deflection of beams, here we have 6, 7th will be the thin cylindrical cells, as well as 8th will be column studs, and chapter 9 will be theories of failure. Theories of failure will be the chapter 9. So here we have total 9 chapters. Here we have total 9 chapters in this subject, total strength of material for both mechanical as well as civil. You're going for ME, that is mechanical engineering, as well as C, that is civil engineering. But very slight difference between these two branch, mechanical as well as civil, from syllabus point of view. For example, theories of failure is in mechanical, but very few question is in civil engineering from this. Very few questions from theories of failure in civil engineering. Okay, let's move ahead. We will discuss importance also, that how much important is the chapter, how much important chapter. I will tell you how many marks, how many questions definitely you can expect from chapter 1, chapter 2, chapter 3 up to chapter 9. So we will go for chapter wise analysis also, that which chapter is very important, which chapter should not left, otherwise you will face problem in gate examination. That means from which chapter there is 100% guarantee or probability of question coming in the next gate examination, that is gate 2025, gate 2025, okay, or 2026. Okay, if you're starting preparation for gate examination 25 or 26, so definitely you should keep all these things in your mind, because once you know the weightage of the whole syllabus of the gate, as well as subject wise as well as chapter wise, then it will let you to plan you better, that which subject has to be focused more and which topic has to be focused more, and from where maximum number of numerical has to be done, because this subject is basically almost 100% numerical. I am saying almost 100% numerical, almost 100% numerical subject, almost 100% numerical subject, formula based subject, but not only formula but very basic. No guarantee that you can solve every problem in the gate examinations. So you should learn the formula, but definitely you should go through the basic concepts also, that how formula derive. Means no need to remember the derivation, but you should get the idea that how formula framed or how formula derived, what is the basic concept, what is the logic behind this formula, so that whenever any difficult question or difficult numerical from this subject comes in gate examination, definitely you can handle it very easily. Okay, that's why concept is very important, as well as since it is a very numerical subject, 100% numerical, so lot of question has to be practiced also. Okay. Okay. Now coming to the first chapter, here we have first chapter, here we have first chapter, and first chapter will be simple stress and strain. Generally, every student or teacher used to start from this subject, this chapter only for the subject strength of material, that is simple stress and strain. So basically, we go for stress basically definition and its type. So generally, what happen? You will say, sir, it's very simple now that stress is nothing but force per unit area. Student used to think like this: stress is nothing but force per unit area, but this is not so. This is only mathematical formula of stress, that is force upon area, but the definition is something else and the meaning is something else. Simply, stress is known as resisting force per unit area. And what is the resisting force? That is the internal force by the molecules or intermolecular force also, that is known as resisting force per unit area. So we should go for very basic concepts for stress, that what do we mean by stress basically, and then its type. Its type means, suppose you're going for stress, normal stress sigma as well as shear stress tau. So what is normal stress as well as shear stress? For example, if here we have a rod and load is applied here. If load is applied here, let's say load is applied here, that is P is the force and A is the cross section area. A is the cross section area. Then what should be the value of stress, normal stress on any particular plane? So here, suppose the plane will be like this transverse plane here we have. So we will sigma is equal to P by A. Sigma is equal to P by A, that is force per unit area or load per unit, like this only. And here on this particular plane, the transverse plane, if you go for the tau, tau will be equal to 0. That is the no shear stress. But suppose if we change the plane, this is all about this plane, sigma will be this much and tau will be this much. Suppose change the plane, plane will be like this. For this plane, both will exist here. Both will exist here. The value of sigma will be different. That is P by A multiplied by cos square theta, and the value of tau will be P by 2A multiplied by sine 2 theta, multiplied by sine 2 theta, like this only, depending on the value of theta. What is the value of theta? How much is the angle? Depending on the value of theta, that is the plane orientation, we will get the value of sigma also, and we will get the value of tau also. That's why I'm telling you that only a formula is not enough to solve questions in this subject strength of material, but we should come to know the concepts also in the best way, so that we can handle every problem. So we should go for stress and stresses in types first of all. Okay, in normal and shear, in normal we have tensile stress also, compressive stress also. So we should go for all these types of stresses. Okay, and this is very basic subject. If we don't know the stress in the best way, then we don't able to solve the rest of the chapter subjects in mechanical as well as civil. For example, fluid mechanics, fluid machinery, as well as structural analysis, as well as machine design, like this only. So we will not able to solve the rest of the subjects if this subject is weak. So this subject has to be done very properly. Okay. Now, second, strain and type. That what is normal strain? That is change in length to original length, as well as what is shear strain gamma. That is the angle through which the body tilt. That means normal strain, shear strain, every thing we should cover about strain, that basically what is strain and what are the types of strain. First of all, from here questions will be very means, if we can say that questions will be very easy, formula based also, but sometimes question can be difficult also. So you should go for very basic concept, so that if different form, different question will be also there in the examination, definitely you can able to handle. And let me tell you, this chapter, the first chapter is very lengthy also. So many topics in the first chapter. First chapter is very lengthy, right? Very big chapter, but 100% guarantee of at least one question, 2 marks from here. 100% guarantee of at least one question of 2 marks from this chapter, first chapter, that is simple stress and strains. Then we'll go for the Hooke's law, that is stress directly proportional to strain, and elongation formula delta L will be equal to PL by A into E. That what is the increase in the length after the application of law. Very important formula. This one is very important formula. From here, so many questions asked already in the history of the GATE examination. Okay, so very important. So what is the increase in the length? Suppose here we have a rod, and after the application of force, the length of the rod increases by some amount delta L. This is the delta L, and this is the original length L here. So delta L will be this much, PL by A, very important formula. Do not forget, very important formula. Okay. Now here we have, as you can see, here we have a Another topic, the elastic constant and relationship. For example, elastic constant, Young's modulus, modulus of rigidity, Poisson's ratio, and bulk modulus. And relation between these three, that is E equal to 2G 1 plus mu, E equal to E is equal to 3K 1 minus 2 mu, 1 minus 2 mu, and E equal to 9 kg, 9 kg upon 3K plus G, upon 3K plus G. So here we have 9 kg upon 3K plus G. This will be the value of E. So relation between elastic constant, here we have very important formula, definitely. And now coming to the thermostress, very good topic. But sometimes you student used to just mug up the formula, but you should go for concept. So after this video, this is the introduction video of this subject as the strength of material. In this video, I will be discussing the weightage, as I will be discussing the importance of the subject as well as the important topics also. Okay, but in the next video, I will be covering this subject, strength of material, one by one, first chapter, second chapter, third chapter, and so on. I will be teaching all the topics of this subject on this YouTube channel of Gate Forum. Okay. So thermostress, generally we have only two stresses. One is the fully free case, and whenever fully free case, here we have the value of thermal stress will be 0 first of all. And another one is the fixed case. Suppose if the rod is fixed on both the sides. If rod is fixed on the both the sides, the value of thermal stress will be E into alpha into delta T. E alpha delta T here we have. Okay, then coming to the stress and curve, these two are very important case. So many questions in the history of gate examiners from these two topic. That's why this has to be covered in the best way. Okay. Now stress and curve, here we have like this stress and curve, you have seen so many times in your book. So we should go for the different point. What is the proportional limit, elastic limit, upper limit point, lower limit point? What is the ultimate point? What is the fracture point? Everything we should discuss in the best possible way, as well as numerical also. Resilience, toughness, everything. Resilience, toughness, everything from this. Because we know that 100% numerical, 100% numerical from this subject. 100% numericals from these subjects. That's why some of the students used to think that this subject is very tough subject, a very difficult or hard subject, but this is not so. Once you get the concept in the best possible way, this subject will be the easiest for you. Easiest for you. Just get the formula, get the idea, and just solve any problem in the gate examination. Okay. Okay. So stress and curve is also very important. Now moving to the next one, that is the second chapter. Here we have principal stress and strain, which is also known as Mohr circle chapter. Which is also known as Mohr circle chapter. Here we have second chapter. Second chapter starts from here, and in this second chapter, basically we should go for the Mohr circle. And I think in your university or college, every student comes to know about Mohr circle. They used to draw Mohr circle, but here approach will be different, not just like college. No pencil, no rubber, no cutter, no protector, no rounder, nothing. Just school level mathematics only. That here we have, suppose here we have a Mohr circle. Then where should be the center? What should be the radius of Mohr circle? What should be the value of sigma 1? What should be the value of sigma 2? Like this only. All these things has to be done. All these things has to be done only. And some special cases also. Some special cases also. Some special cases also. For example, if suppose if we have hydrostatic loading. Okay, if we have hydrostatic loading, if we have pure shear, then we should deal all these things, that what is the special in these two cases. Okay, so first of all, here it is strain analysis, stress analysis. That means we need to calculate the value of stress on the different planes. Suppose if we have a body, suppose if we have a bar, and it is subjected to a force, tensile force, let's say P here. Let's say tensile force P here. So what's the value of stress on this plane? What's the value of stress on this plane? Like this only. What's the value of stress on this plane? So we have different plane number one, it's plane number two, it's plane number three. We can have infinite number of planes in the body at the different angle, at the different angle. Suppose here we axis at different angle theta, we have different value of, we have different planes, and the different planes having the different value of sigma and tau, that is normal stress, shear stress. On plane 1 we have sigma 1 tau 1. On plane 2 we have sigma 2 tau 2. Here we have. On plane 3 we have sigma 3 as well as tau 3. Here we have like this only. On different planes we have different value of stresses, and we need to calculate these stresses by both the method, by formula method also, and by Mohr circle method also. Two methods here we have. One is the formula method. Just go for the direct formula. One is the formula method. Just go for the direct formula. And the second one is, here we have, that is the Mohr circle. We should go for the Mohr circles method. We should go for Mohr circle method. Okay. So here we have 2D or biaxial plane stress system, and 1D also here we have, 1D also here we have, 2D also, and 3D is not in our syllabus. Don't worry for 3D, just go for 1D and 2D. We should go for very basic concepts of 3D only, but 1D and 2D fully, right, in depth we should go for 1D and 2D Mohr circle. Okay. So what is the 1D and 2D? In 1D we have, this is 1D, that if load is applied only in the one direction, only in the x direction, only sigma x here we have. What about 2D? Suppose here we have state of stress like this, that here we have sigma x, here we have sigma y like this only, and here we have tau xy also. This value sigma x, this value sigma y, and here we have the value of tau xy, the value of tau xy here like this only. Suppose here we have 2D state of stress, 2D stress of stress, then we need to calculate the value of sigma and tau here for the different plane. What is the value of sigma, as well as what is the value of tau, as well as so many things here like this only. So many things we should go for. So Mohr circle is very important. Second chapter is also very important. I can say 100% guarantee of one question from this topic. 100% guarantee of one question from this topic. You should definitely go for this Mohr circle. Okay. So now Mohr circle for 2D plus 3D. Already told you that 3D is not so important, but just get some little bit idea about 3D. Little bit idea about 3D. But 1D and 2D should be in very depth. 1D and 2D should be discussed in very depth, because so many questions already in the history of GATE examination in the last 32 years, so many questions. And then here one topic, that is strain rosette, also very important. But questions, very less questions in the GATE examination. Okay, very less questions. So should I write here less number of questions in PYQ? PYQ. Previous year very less number of questions. So if suppose if some student is not preparing for the first rank, if some student is not preparing for, let's say, top 100, top 500 rank, then he or she can leave this topic strain roses, or right. He or she can leave this topic strain roses. That is not a problem, because probability of questions coming from this topic will be very less, very less. Now here we have third chapter. Third chapter is also very important. Third chapter is very important, which is also known as shear force diagram as well as bending moment diagram, SFD and BMD. 100% of guarantee of one question from this topic in the GATE examination every year. First of all, from the third chapter, shear force bending moment diagram. Okay, so first you start from the types of beams and support. What are the types of beam? For example, cantilever beam, simply supported beam, overhanging beam, fixed beam, like this only. Okay. Now calculation of shear force and bending moment. That is, we should go for calculation and shear force for the different cases, for the different beams. Okay. And then should go for rules to draw the shear force as well as bending moment. For example, suppose if here we have a simply supported beam, and load is applied at the center, point load is applied at the center, W, and we need to get the value of shear force and bending diagram. So here we have shear force diagram like this, that shear force will be like this, W by 2 positive side here, and then minus W by 2 negative W by 2 negative side here, like this only. This side here we have minus, this side here we have plus. So here plus W by 2, and here we have minus W by 2. So this will be the shear force diagram, and highest value of shear force will be W by 2. And similarly the bending moment diagram will be like this. For this case, here we have bending moment diagram, that WL by 4. WL by 4 is the value of maximum bending moment, and minimum will be 0 here. Maximum will be at this point, at the center point only. Here at the center point, see, let's say here maximum bending moment will be WL by 4. So for the various cases, right, here I have told you about the simply sorted beam with the point load. It can be different types of loading and different types of beam. It can be cantilever, it can be overhanging beam, it can be UDL, it can be point load, multiple loads also, concentrated moment also. So many cases we have, so many cases here we have. So this chapter is very important, because if once we draw shear force and bending diagram in the best way, then only we can move to the next chapter, that is bending of beams. Because in bending of beams, right, we need to calculate the value of maximum bending moment. So definitely this chapter should be very clear. 100% one question guarantee from this chapter. Very, very, very important chapter. That is shear force as well as bending moment diagram here we have. Okay. Now we have relation between the shear force and bending moment diagram, very important. And condition of maximum bending moment, that where we can have maximum bending moment. Suppose if we have shear force diagram. So by looking at the shear force diagram, if suppose shear force jumps somewhere or shear force 0, let's say here shear force diagram will be like this. Suppose if shear force diagram will be like this, just look at here. If shear force diagram will be like this, so where we can have maximum shear force. So here at this point or here at this point. At any point we can have maximum bending moment, because by looking at the shear force diagram, where shear force 0 or changing the sign, we can say at this point we can have or the possibility of maximum bending moment. Okay, very, very, very important topic. Then shear force diagram for uniformly varying load, uniform distributed load, with internal hinge questions also like this one, very important. So we should go for all these things. We should go for all these things. Then the fourth chapter here also, this fourth chapter, I think we should combine third and fourth chapter, because both are almost same only. Because once we get shear force bending diagram, we need to calculate what is the maximum bending diagram, and then we should go for only one formula in this chapter. First of all, introduction of pure bending, that what is pure bending, and then theories of pure bending and bending formula, that is sigma by y is equal to m by I is equal to E by R, like this one. This formula should be in your mind always if you're preparing for gate examination, and from here sigma is equal to m by I multiplied by y. This is the value of bending stress at any layer. At any layer, bending stress at any layer. Suppose here we have a beam and load is applied, bending load applied. So this is the topmost layer, then the second topmost layer, third topmost layer, then neutral layer, then layer, then layer. So many layers here we have from the topmost to bottommost layer. So by using this formula, we can get the value of bending stress on the different layers. Okay, and then we can combine stress. Combine stress means combination of both bending plus direct stress. Combination of bending stress plus direct normal stress or direct axial stress. Direct axial stress. Combination of bending stress plus direct axial stress. This one is also very important. Okay. Now we should go for eccentric loading, which is also one combination of bending plus direct. Then shear stresses in beams, not so important, but we have questions in gate examination, but not so important. Shear center also not so important, but we have questions from this topic in the civil engineering and not in the mechanical engineering. Not in the mechanical, only from the civil engineering from this topic, but very less question in the gate examination. Okay. Now, beam of uniform strength. This topic is also not so important. Very less question in PYQ. Very less question, but we should go for that. What is uniform strength of beam, right? Now, next chapter here we have. Next chapter here we have torsion. Here we have fifth chapter. This one is the fifth chapter, that is the torsion, and in torsion, very, 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 very important. And here also I can say 100% guarantee of one question from this topic, torsion. That is, what is pure torsion? What is polar section modulus? Design of shaft against torsion. So basically, basically here we are going for the torsion formula. That is T by J is equal to tau by R is equal to G theta by L is equal to G theta by L. That what is the value of tau or tau max, or tau is equal to T into R by J, or the value of tau max you can say, that is T into R divided by J, like this only. Suppose if here we have shaft and torque T is applied here. Here torque T is applied here like this only. So here we can have radius of the shaft. Okay, then polar section modulus J, that is pi by 32. That is pi by 32 into 10 raised to 4, like this only. Okay, so when we will go for the chapter wise after this video, I will be coming for so many videos of, I will be coming with the so many videos of strength of metal subject with a different chapter. In that videos, I will be telling each and everything about the concepts. But here, I'm not telling you the concepts. I'm telling you the important areas or the type of questions can come in the next gate examination. Okay. So here we have basically torsion formula, very important. So many questions from this torsion formula only. Okay. Now power transmitted by the shaft, that how much power transmitted by the shaft, power is equal to 2 pi nt by 60. T is the value of torque. 2 pi nt by 60. N is the rotation of the shaft, rotation speed of the shaft in revolution per minute, rpm, like this only. Then hollow and solid shaft, we should compare hollow, but this topic you can leave also comparison because less questions, right? So hollow and solid shaft. Then combined stress, here we have combination of both bending plus twisting, bending stress plus twisting stress, bending plus twisting combination. Once again, here we have combined stress. This topic is also important, so we should go for the combination of bending plus twisting. And here I can say show you, here we have combination of combined stress, that is bending plus direct axial stress, bending and axial stress. But here we have combination of, here we have combination of bending plus twisting stress, very important, we should go for. Okay, as I already have told you, the torsion is also very important, and also one guarantee of one question from here. Okay, now deflection. Here our next chapter, chapter number 6. Here we have sixth chapter, and this one is also very important. From sixth chapter, 100% guarantee of one question, 100% guarantee of one question from this topic in the examination. So here we have different methods: double integration method, Macaulay's method, moment area method. Okay, then strain energy method. But let me tell you which method is very important. Which method is very important? I think personally, because I have teaching experience of so many years, almost 10 to 12 years, and I am also from IIT Kharagpur. I have cleared my GATE exam. That's why on the basis of my examination preparation as well as on the basis of my teaching experience of last 10 to 12 years, I'm telling you that students are going through double integration method. No use at all. Don't go for this. You are wasting your time. Just you are wasting your time. Don't go for the Macaulay's method. You are wasting your time. Just go for the moment area method. Very important moment area method. Most important, most easy and most safe method. It will save your time. Easy, right? You can understand easily. Calculation is very less. That's why this method is very important. Easy, less calculation, safe. That means no chance of any type of error mistake in the examination. That energy method is very also important because it happens sometimes that energy method or Castellan method both are same. So we should go for these two also. No need of conjugate. I think you need not any this type of conjugate method in the GATE examination. But even though if you want, you can do this. You can do this. Method of superposition, very important. Very important method of superposition. So many questions directly asked from this method of superposition for the deflection, and just use the formula, get the answer within 30-40 seconds or max to max within 1 minute you will get your answer. Then Maxwell reciprocal theorem, not so important, but we can go for this method also. And then we have next chapter, that is chapter number 7. Then we have chapter number 7, seventh chapter. Here we have seventh chapter. Here we have things. So not 100% guarantee of question from this topic in every year, but even though we have some questions in the last 32 years, so definitely we should go for this also. The stress, we have three different types of stress in the thin cylinder, that is axial stress, radial stress, as well as circumferential or hoop stress. Circumferential or hoop stress. So we should go for all the three types of stress first of all. Then maximum shear stress for thin cylinder, what is the value of tau max? Very important formula. Tau max formula, I think very important. So many times asked in the examination. Tau max, very important formula, you should go for this. Okay, and then combined stresses for thin cylinder. Actually in thin cylinder combination is not so important, but we will go for. And strains in the thin cylinder, very important, very important strain. That is strain, radial strain, axial strain, hoop strain, like this only. Axial strain, so radial strain, hoop strain, as well as axial strain. Very important, we should go for this strain formula. So when we will go for this chapter, because already I told you this is the first video of mine on this YouTube channel platform. So once I will move to chapter 1, chapter 2, chapter 3 in the coming videos, I will discuss all the formulas. I will teach you the first chapter, second chapter, third chapter, like this only. Okay. Now here we have eighth chapter, chapter number 8. Here we have eighth chapter. Here we have eighth chapter, column stud, and this chapter is not so important, not 100% guarantee of questions every year in the examination, but but so many questions already asked in the previous GATE examination in the last 32 years, but not every year. No guarantee of 100% question from this chapter every year, but so many questions already asked, so we should go for. And what is the important thing for this chapter? That this chapter is very easiest chapter. I can write this as easiest chapter. easiest chapter, you should go formula wise also. Easiest chapter means for this chapter you can go for formula wise also. What do you mean formula wise? Suppose you are not interested for derivations. Suppose you are not interested for anything else. So directly get the formula, use the formula and get your answer in the examination. Very simple. Or I think this chapter column is the easiest chapter in the whole strength of material for both mechanical as well as civil point of view in your gate examination. Okay, so what to go for in this chapter, that is the slenderness ratio and types of column. Generally in our syllabus we have long columns. Generally in our syllabus we have long columns, so you would go for long columns. Don't go for the short columns, don't go for the medium column. Generally in our syllabus we have only long columns, which is also known as Euler's column, okay. Then critical load, very important. This one is very important. I think this one is very, should I write, very important topic in this column chapter. Very important. General question asked from here only. Formula only, very important formula. Okay, just mug up the formula. Suppose this chapter is very easiest. Now, if don't want to go for basic concepts, don't want to go for the derivation, no problem. Just mug up the formula. Very easy question in the examination. Just apply the formula, you will get your answer. Okay, simple. And here we have Rankine's formula for medium column, not so important. We'll go for. And here we have last chapter, that is the ninth chapter. Here we have ninth chapter. Here we have, and this ninth chapter here we have theories of failure. Ninth chapter here we have theories of failure. So this is also a very important chapter, but no guarantee that every year one question will be here. Not 100% guarantee that one question will be formula wise. You can go for formula wise also, and if you apply formula, you will get your answer. Right. Suppose you are not interested for the derivation of formula, you are not interested for the basic concepts much in this chapter, chapter number 9, theories of failure. Even though it is okay, you just go for formula wise and you will get your answer. So I think I have covered all the 9 chapters. So I have given you one very clear idea that how to proceed with this subject strength of material if you are appearing for, if you will be appearing for gate examination, gate 2025 or 2026, whether from mechanical or from civil only. So as I said, important, and sixth very important, fifth and sixth very important, first, second, third. So first very important, second very important, third very important, fifth and sixth very important chapter. From there, these 5 chapters, 100% guarantee of one question in the gate examination, 100% guarantee. Okay, so we should proceed in this way, 100% numerical subject. That's why formula will be very important. Once you will go for this subject now, I will suggest you that you should go for short note copy or formula note copy also. You should prepare your formula note copy first thing, because what is the key to success in the gate examination? Let me tell you only 2 things. One is the concept should be best. First thing is the concept. Concept should be best first of all, and second thing, more number of question has to be practice. More number of question has to, only concepts plus practice and nothing else. Suppose if your concepts are very good, suppose if your mentor or your teacher or your faculty is very good and he has taught you the subject in the best way, means your concepts is very good and you practice a lot of questions, so definitely nobody can say that you will not be a topper. Definitely you will be topper once your concept is very good and you practice a lot of questions. So here at Gate Forum, we are going for best concepts for this subject strength of material, because I will be teaching the subject strength of material in the best possible way, because already I have told you that I have some experience of so many years, right, 10 to 12 years, and I am also from IIT Kharagpur, right. So I have full experience. That means I have analyzed all the 32 years paper, of the last 32 paper, and I come to know that which area from where questions will be numerical type, questions will be of very easy, questions will be like formula based type, like this only, questions will be very conceptual. That's why I told you that chapter number 1 is very important. Okay, chapter number 1 is very important, chapter number 2 is very important, chapter number 3, 5 and 6 very important chapter, means 100% guarantee from these chapters. Okay, so this is my first video on this platform, and in this video we have discussed that syllabus of strength of material, weightage of the strength of material in the last few years, as well as what is the importance of this subject and how we should move in this subject with the different chapters, chapter 1, chapter 2, like this only. Here already I have discussed all these things here. So definitely I will suggest you that don't afraid with the gate paper. Definitely, if you are trying to crack or to score best in your gate examination, so only one thing will be very important to you, that your teacher should be best. That means which can build a very good concept for you first of all, and second thing, you should practice a lot of questions to improve yourself. Okay, only two things. Let me again tell you the two things by which you can score best in your coming gate examination. The first thing is the best concepts by best teachers, and second thing, lot of question has to be practiced from BYQ, from some standard books, from EAC objective, and from test series also. Okay, so suppose if you will be starting your journey from next month or next to next month for your gate 2025 2026, so definitely this subject has to be your first subject from mechanical civil, and please go through the concepts in the best possible way, so that you will score 100% in the subject, and rest of the subjects will be also very good for you. Okay, so here in my first video, I have given you just one idea of this subject, and I will be coming for chapter wise also. So I will be coming for the first chapter of strength of material on this YouTube platform. So definitely we will discuss all the important formula concepts of chapter number 1 here on YouTube channel. Okay, so thank you all for watching this video, and just like and subscribe the channel, and if you have any queries, question, please write in the comment box. Definitely I will reply you there. Okay, so bye all of you, and just start your preparation for next gate examination in the best possible way, and connect with us so that we can start our preparation in the best possible way. Okay, okay, bye all of you, bye.